Hi everyone, welcome back to another practice question on complex numbers. This is taken from the 2020 Dunman High Paper 1, question number 3. If you're all ready, let's jump right in. We are tasked to use an Argand diagram to show that the angle OWZ is pi over 12 radians. Now before we do this, let's try to represent the complex numbers Z and W on the diagram with whatever information that you might have. So since Z has an argument of minus pi over 3, this will be in the second quadrant as it is measured from the positive x-axis in a clockwise direction. Now W has an argument of a positive pi over 4, so we can place it in the first quadrant, which is anti-clockwise from the positive x-axis and with a modulus of 2. Now this information is something many students might find challenging, the argument of W minus Z. Now this argument, when represented on the Argand diagram, is actually the vector ZW. Recall that, if you want to find vector AB, for example, it is the position vector OB minus the position vector of OA. So it's the same for this. For vector ZW, it is denoted by W minus Z, which is the argument. And we can denote the argument of this angle that ZW makes with the positive x-axis over here, which is given to us as pi over 3. So very simply, we can find angle OWZ by taking pi minus pi over 4 minus 2 pi over 3, and this will be equals to pi over 12. Now don't forget to write the word shown so that you can answer directly to the question. Now in the next part, our objective is to find Z and W in the Cartesian form. Now since the imaginary and real components are not given to you directly, not to worry, what we can do is to employ the trigonometric form of Z and W to help us convert into the respective Cartesian forms. The trigo form is also used because we can make use of the modulus and the angles that are readily available to us from the Argand diagram. So let's try to find W first because it is easier. We can express W in the trigo form by writing W equals to 2, open a bracket, cosine pi over 4, which is the argument of W, plus I sine pi over 4. Now to remember the trigo form easily, always remember that cosine, which starts with a letter C, comes first in the alphabet before S. So cosine and sine. Simplifying, we have square root 2, open a bracket, 1 plus I, close bracket. Now this is not the final answer because we need to express A and B to 3 significant figures. Always answer to the question, so therefore W is equals to 1.41 plus 1.41i. Now in order to find Z in the form of A plus BI, we must first find the modulus of Z, and this is denoted by OZ on the Argand diagram. The question has also hinted to us that we can make use of the angle OWZ, so maybe let's try to use the sine rule so that we can get the length or the modulus of OZ. Now OWZ is pi over 12, which means that OZW is simply pi, 180, minus pi over 12 minus pi over 4 minus pi over 3, which gives us an angle of pi over 3. Now using the sine rule, we will have 2 over sine OZW equals to OZ over sine angle OWZ. Simplifying, we will have 2 over sine pi over 3 equals to OZ over sine pi over 12. Now making OZ the subject, the value would be 0.59772. So substituting back to the trigo form, Z is equals to 0.59772 because that is the modulus. Open a bracket, cosine minus pi over 3 plus I sine minus pi over 3, and simplifying, we will have the form 0.299 minus 0.518i. Now this is the Cartesian form of the complex number Z. Now I do hope you learned something from this video. If you would like to improve your complex numbers techniques, do check out the complex numbers playlist. Run through every single question in them so that you can learn as much as you can. I'll see you in the next video. Thanks for watching.